Good morning, folks. Today we're going to be talking about putting it all together. Before we get going, I want to talk about conceptualizing. You need to conceptualize what we're doing, not just memorize a bunch of formulas. Memorizing is fine, right? But you're going to get to the point where you have to put some stuff together. And today's one of those days we have to put stuff together. So the goal here is for you to think about and be able to apply the information that you have. Okay? So let's go ahead and get going. See what we've got here. Let's say I have a 2-gram sample of water. What's the mass of hydrogen that it contains? That's a tough question, but I think that you can do it. So I'd like you to take a couple of minutes, pause the video, look at this, write down everything you can think of that might apply, and see if you can solve the problem. Okay? Give it a shot. Even if you can't get all the way through it, give it a shot. All right. So let's write down what we know. We have a 2-gram sample of water. We know that water is H2O. Right? And because I'm dealing with grams of water, I can figure out how much water weighs. And hydrogen is 1.0079, and there are 2 of them. And I have to add that to 15.999, which is oxygen. And that's going to give me a total of 18.015 grams per mole of water. All right, so that's a piece of useful information. Can I use that to get to moles? Well, if you haven't done that, pause the video and get there. And if not, I'm going to do it right now. All right, so you're starting with a 2.00 gram sample of water. And I want to convert from grams of water into moles of water. And I know that in 1 mole of water, it weighs 18.015 grams. Right? So if I do that math, that's going to come up with 0.111 moles of water. All right. You might have gotten that far and gotten stuck, because this is something that we haven't talked about, but certainly something that you can think of and figure out how to do. If you have let's just think about this, step back from the problem for a second. If you have one molecule of water, how many oxygens do you have? Well, I'll have 1 oxygen. How many hydrogens will I have? Well, I'll have 2 hydrogens. So I'll have 1 oxygen and 2 hydrogens for every 1 water. So I can do that with moles as well. So if I have 0.11 moles of water, that means I have 0.111 moles of oxygen. It also means I have twice that much hydrogen. So I have to have 0.222 moles of hydrogen and 0.111 moles of oxygen to make up 0.111 moles of water. Make sure you get that concept, because that's key. Right? Because that will allow us to figure out the mass of hydrogen. Because if we know that we have 0.222 moles of hydrogen, we should be able to figure it out. So let's try that. So we have 0.222 moles of hydrogen, and I want to figure out how much that is in mass. And I know that for every mole of hydrogen, I have 1.0079 grams of hydrogen. And if I do that math, then I come up with 0.224 grams of hydrogen. That's my final answer. So guys, what did we do? We went and took information that we knew, converting between grams and moles and grams, and then we used some logic. And our logic is this stuff that's down here. It says for every mole of water, we have 1 mole of oxygen. For every mole of water, we have 2 moles of hydrogen. It's important to be able to think through that logic. Okay? Let's try another one. See if you can do better on this. Go ahead and pause the video. See if you can figure out how many grams of oxygen are present in 8 grams of sulfuric acid. All right. Welcome back. Did you make some progress? Did you figure out the formula for sulfuric acid? That's key. formula for sulfuric acid is H2SO4. So hopefully you figured that out. All right. Another thing to think about is if you just estimate and think about this for a minute, if you have 8 grams of sulfuric acid, how many grams would you have of oxygen? Well, you can't have more than 8 grams. So it's got to be somewhere between 8 and 0. Might be 4, might be 5, might be 6, might be 3. Who knows? We have to figure that out. All right? But it should be somewhere in the middle. Now, if you started with something other than H2SO4, again, pause the video, go back, and do the rest of the math properly. All right? But see how far you can get on this by yourself, and then come back. All right? Well, I have to figure out how much H2SO4 weighs. So that's 1.0079. And I have to multiply that by 2, because that's hydrogen. And I have to add to that sulfur, which is 32.066. And then I have to add to that my oxygen, which is 15.999, times 4, because I got 4 of them. And that's going to be equal to 98.078 per mole of H2SO4. All right, so that will allow us to figure out how many moles of H2SO4 we have. So if I start with 8.00 grams of H2SO4, and I convert from grams of H2SO4 to moles of H2SO4, and for every mole of H2SO4, I know that it weighs 98.078 grams, because I just figured that out. If I do that math, I come up with 0.0816 moles of H2SO4. Great. Now, how many grams of oxygen are present? Well, before we do that, let's think about our ratios here. So for 1 mole of H2SO4, that's comprised of 2 moles of hydrogen, 1 mole of sulfur, and 4 moles of oxygen. So that means I have, since I care about oxygen here, I have a 1 to 4 ratio. So for every mole of H2SO4, I have 4 moles of oxygen. So if I take the 0.0816, which is the number of moles of H2SO4, and I multiply by 4 to get my moles of oxygen, right, then that will give me 0.326 moles of oxygen. Well, now it's easy. Now I need to convert from moles to grams. I know how to do that. So 0.326 moles of oxygen. And I want to go from moles of oxygen to grams of oxygen. So I'm taking 1 mole and going to 15.999 grams. And when I do the math, that's going to give me 5.22 grams of oxygen. So does that make sense? We said that we had to have less than 8 grams of oxygen. We got 5.22. Yeah, I can believe that's correct. All right, let's try one more. This one's a little bit different. You're going to have to work this one a little bit backwards. All right, you've got a sample of phosphoric acid. Contains 12 grams of oxygen. What's the total mass of the acid I started with? So think about that for a minute, and then come back to me. All right, the first thing you should notice is you've got oxygen, and my formula for phosphoric acid is H3PO4. And I'm looking for the total mass of H3PO4, and I know the mass of oxygen, which is 12 grams. All right, well, that tells me that my total is going to have to be bigger than 12 grams. I don't know how much bigger. It might be 15, might be 18, might be 20. I don't know, but it's bigger. All right. So let's see what happens. Now, to be able to do this, of course, I need to figure out my molar mass of the H3PO4. So I have, for my H3, I have 1.0079, but I've got 3 of them. And phosphorus, I've got 30. I got to look that one up. Don't know that one off the top of my head. 30.974. and there's only one of those. And oxygen is 15.999, and there are 4 of those. When I multiply and add all those together, I get 97.994 grams per mole of H3PO4, phosphoric acid. All right, I'll need that a little bit later. So let's look at how many moles of oxygen I have. Well, I'm starting out with 12.0 grams of oxygen. I'm going to write OX just so you're not confusing it with O. And I'm trying to go from grams of oxygen to moles of oxygen. And 1 mole of oxygen is 15.999. Right? And when I do that math, well, that's almost a mole, isn't it? Well, in fact, that is 0.75. It's 3/4 of a mole, 0.75 moles. So now what? Well, I have a ratio between oxygen, which is here, and the entire H3PO4s. So what is that ratio? Well, I have 4 oxygens will give me 1 H3PO4. So my relationship is 4 to 1. So for every 4 oxygens, I have 1 mole of H3PO4. So if I take 0.750 moles of oxygen, and I divide it by 4, because I have a ratio of 4 to 1, right, that's going to give me 0.1875 moles of H3PO4. Well, I know what H3PO4 weighs, so I'm going to take 0.1875 moles of H3PO4, and I'm going to get rid of moles of H3PO4 and go to grams of H3PO4, and it's 97.994 grams in 1 mole. When I multiply this out, I come up with 18.4 grams of H3PO4. Well, does that make sense? It's more than 12. So that kind of makes sense to me. So I think we probably have the right answer. Folks, what we've done is we've done a lot of reasoning here. We've done a lot of logic. We've done ratios. We've put some things together that you should know how to do. Right? So bottom line is, as you think about these, the goal is that you start to think about how to work with chemistry and how to apply the information that you know. You're synthesizing information together. All right? That's it for this podcast. That's it for the unit. If you have questions, come see me in class, and see you then.